Hello everybody, and welcome back to some more Universe Sandbox 2. Today, we are going to be taking the outer planets, Neptune, Uranus, Saturn, and Jupiter, and we're going to be taking them into roughly the same distances that Mercury, Venus, Earth, and Mars are from the Sun. Not respectively, though. So, without further ado, here we go. We're going to create a new empty simulation. We're going to add the Sun, which is right about here. We're going to add the Sun right there. We're going to click on the Sun. We're going to be like, okay, motion, position lock on. And then we're going to zoom way out. And then we're going to start adding planets. Now, I've pulled up over here on my other monitor here. We've got Mercury, which is about 57.91 million kilometers away from the Sun. And we're going to put Jupiter here. We're also going to pause the simulation just in case this decides to go wacky. Okay, what did I say? 57 million something? Okay, so 57.9 million. This is going to be very hard. What is that? That is as close as it's going to be getting to the Sun without me messing around with things a lot. Now, what else? Okay, we need Venus distance from the Sun, and we're going to put Saturn here. And that's about 108.2 million kilometers. Okay, that's really close. All right, now Uranus, whatever. Shut up. Stop being so immature. Jeez. Uranus is going to be where Earth would be, approximately, which is about 1 AU away from the Sun. No, it is 1 AU away from the Sun. And this is about 149.6 million kilometers. No, that's 0.9. 1 AU. There we go. And then Mars, which we're going to put Neptune out there, is... Oh, hold on. This is in kilometers, not AU. It's about 227.9 million kilometers away. However, once you get to a certain distance in this game, it just so Mars is about 1.52 AU. 1.52 AU. There we go. Cool. And then, I should find out Ceres. Okay, let's look this up. Ceres. Distance from Sun and AU. There we go. About 2.77 AU. So we're gonna put, since they have a planet 9 here, we're just gonna put it about, what did I say, 2.77 AU? Or about 414 million kilometers. So 2.7. Okay, looks like that's about as close as we're gonna be able to get it. Alright. So now we have these planets orbiting the Sun, and the reason I wanted to put these so close to the Sun is to see what would happen if all of the gas got stripped off, all of the hydrogen got stripped off of these planets. Now, this may not be a 100% accurate representation of what would happen, but it'll be mostly okay for the purposes of this video. So we're gonna, Jupiter, we're gonna zoom in on you real quick. Just, what? Jupiter. Stay calm. Okay, alright. Now that we've arrived at Jupiter, we're gonna follow it and see what happens. Now we should see, okay, temperature should be skyrocketing right now. And this, I don't think this can account for any greenhouse gas effect, so we're just gonna observe basically the surface temperature, not the inner temperature of Jupiter at this point, because that would be much hotter due to greenhouse gases and that sort of thing. So Jupiter's doing that. Let's see, it should be losing mass, and I don't know how to, oh wait, here we go. Yeah, all right, so mass loss total, it is losing quite a bit of mass. Excuse me, that was rude of me. But anyway, if Jupiter were to slowly start losing all of its gas, and I don't know that we'll be able to see this, I'm just going to speed this up to see if... Yeah, it's not losing mass fast enough for us to see that. So I'm just going to strip away its mass very slowly, or it's all of its hydrogen. Oh wait, no, crap, that's not what I wanted. Okay, so hold up. All right, Jupiter, go away. Add another Jupiter. Okay, this is awkward. I kind of screwed this up. All right, Jupiter, where did you go? Jupiter. What did I say? It was 57 point something. 57 point. That is good enough for me. Wait, why didn't it? I didn't place it. There we go. Alright. Now we're gonna zoom back in on Jupiter here. And instead of just changing, because all we did there is we changed all of its mass to be silicates, basically. Because the only other thing we see in here is the silicate, which is at the core. So what we're going to do, 6.8 masses of, 6.38 masses of Earth in silicate. So I'm going to take away all the hydrogen and then replace the silicates with 6.38. Okay, so 6.38. And we know that Jupiter has some sort of iron core, so I'm going to say, like, yeah, that looks good. That looks good. I have no idea what the actual numbers are, but that looks good. So, this, in Universe Sandbox 2, is what Jupiter would look like if it were I think it's called a Cleothian planet, maybe? I honestly don't know for sure. But basically, what that means is it's a gas giant with all of its gas stripped away. So this is what Jupiter would look like. Just a big ball of silicate and iron floating around in space. About where Mercury would be if it should have been in Mercury's position. Okay, now that we've seen this, we're going to... Where is... Oh, there's Saturn. Alright, let's go over to Saturn. And we have arrived at Saturn. Now, we're not going to see the rings here just because it doesn't simulate those and there's no like texture or anything for that. So don't complain at me. Complain to Universe Sandbox 2 developers. Thank you. But we're gonna do the same thing with Saturn here. We're gonna materials, and we see a bunch of numbers here. So I'm going to write these down real quick somewhere. Like, how about this notebook here? This is, oh crap. This notebook looks good. All right. So we got iron. Iron is 23.2 moon masses. Or lunar masses, I suppose. And silicates is 1.90 masses of Earth. Earth. Oh dear Lord. E-A-R-T-H. I'm so bad at spelling. I promise I'm in college. And then we have, what do we have? Water. We have 54.1 masses of the moon. So water is 54.1 lunar masses. There we go. Alright, so without further ado, let's strip all the gas. Let's change that back to 23.2 lunar masses. 23.2 lunar masses. Silicate was 1.90 masses of Earth, and water was 54.1 lunar masses. There we go. And Saturn, make sure I'm just focused on it real quick. There we go. Maybe. No, hold still, Saturn. Saturn, at the distance Venus is from the sun, temperature. It would actually be a mostly habitable planet, except for there's no land anywhere on the planet, and it has a very, I think it's got a very slow, oh no, it's actually got a really fast day-night cycle. So, it would also be way too big. Well, no, it'd just be about a super Earth, actually. So this would be like Enceladus, if it was a... Was it? No, it's not Enceladus. It's Europa, sorry. Europa, if Europa was much, 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 much more massive, basically. And much, 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 much closer to the sun. And that's... yeah. And it seems that Saturn, yeah, it has a mostly stable temperature here. So life could very well exist on this planet. I don't know how to tell. I was gonna look for Earth similarity. Right, I don't remember where that is. Anyway, this is fine. So, this planet would actually be mostly habitable, and it would probably also have an atmosphere, just because of geologic activity on the planet. Maybe it's gotten heated up in the past, it was closer. Basically, what I'm saying is this should have an atmosphere of water, maybe some oxygen and hydrogen, maybe. But that's what Saturn would look like if it were much closer to the sun and was not a gas giant. Pretty cool, actually. I think that's actually really, really, really cool. Let's go now to Uranus. Stop being inappropriate, children. Let's go over to Uranus over here. I don't have a mouse wheel, so don't judge me, okay? Okay, so now Uranus. Here we go. All right. So, we can get a little bit closer. Yeah, all right. So Uranus is a much smaller gas giant. Jupiter is by far the largest. Saturn's the second largest, and I don't remember if Uranus or Neptune is bigger than one or the other, so I'm not going to say anything about that. Well, actually, I could probably figure that out real quick. So Uranus is 14.1 Earth masses. And if we go to materials here, iron is 55.1. Moon masses, or lunar masses, as it should be probably technically called, and silicate. Silicate is what, 2.03 masses of Earth, and water. Oh, there's actually a lot more water on Uranus. That's right, because Uranus is an icy gas giant. I remember now. So water is 10.9 masses of Earth. So let's do this real quick. Take away all the gas. What did I say? 55.1 lunar masses. 2.03 masses of Earth. And 10.9 masses of Earth. So Uranus would actually be like almost 100% water if it were gas-free and orbiting about where Earth would be. It would also be very frozen. Actually, it would probably be mostly just a giant ball of ice. Just because of the temperature here. So, the temperature and that it doesn't have much mass that isn't in water. So, basically, Uranus wouldn't be very habitable unless there was some sort of geologic activity on the inside, but even so, there would be several, I don't know how deep or how big across Uranus is, what its diameter is, but there would be several hundred to 1,000-kilometer deep just ice sheets over a very, very thin ocean, relative to the rest of the planet, close to its iron and silicate core. So, yeah, Uranus probably more than likely would not have any life on it if it were in this position, and it just be just a big snowball in the solar system, essentially. Now let's go to Neptune. Alright, Neptune. Neptune is also a mostly water world. So, more than likely, it's going to be very similar to what Uranus was like. Just a big, big snowball just floating in the solar system. All right, we have arrived at Neptune. Whoa, that was weird. Why did he do that? Okay, let's do this. Oh, I guess Neptune is more massive than Uranus, because Uranus was 14.1 masses of Earth, if I wrote this down correctly. All right, let's do this again. All right, so Neptune, what are you? Okay. Iron, 66.7 lunar masses. Silicate, 2.4 Earth mass, 2.46 Earth masses. And, not hydrogen. Water is 12.8 Earth masses. Alright, let's do this again. And hydrogen gone. What did I say? 12.8 here. 2.46 here. And 66.7 here. Alright, so Neptune, also not very exciting. Probably just be a gigantic ball of ice. A colder ball of ice, too. Much, much colder ball of ice, too. Yeah. And its albedo would probably be a lot higher than it is actually, than it was just a minute ago, whatever it was. Probably be much, much higher because just the nature of ice having a higher reflectivity than water. Water generally absorbs more energy, and ice generally reflects a lot more light. So its albedo would probably be much higher, and it would be much, much colder than it actually is. So let's continue on to Planet 9, the final one. Now we have no idea what Planet 9 actually looks like, what it's actually composed of. It's just, we think it's out there based on the orbits of some asteroids in the Kuiper Belt. Oh, okay. Simulation's still going. Didn't realize that. Okay, that's fine. And why is it doing this? Okay, whatever. Whatever. This is fine! Alright. Now we're back. Planet 9. 10 masses of Earth. Yeah, that's about right. I was trying to remember my astronomy, and we think that's about right. We think that that's what it should be. So, okay, materials, and this one looks like it's mostly a water world too. So I'm just gonna jot these all down again. And then Planet 9, iron, 40.6 lunar masses, silicate, 2 Earth masses, and water is 7 Earth masses. Which means that the iron is just, oh, no, not quite. I was gonna say the iron is exactly 1 Earth mass. But I forgot about the hydrogen. So, alright. 40.6 lunar masses, 2 Earth masses, and 7 Earth masses. Now, this is also just an icy world, and I don't think it has a... Yeah, its rotational period is ridiculously long, so... This is almost tidally locked to the sun. Almost. Depending on its speed. Its orbital velocity, basically. That's what I was going after. But yeah, this would be an icy giant. Or, yeah, an icy giant. Just a gigantic freaking snowball in the solar system. Right about where Ceres would be. So actually, this would be like in the middle of the asteroid belt. So its composition might look a lot different should it be in the asteroid belt where Ceres is at. And anyway, I hope you guys enjoyed this episode. Shout out to this person here for recommending doing this. I really appreciate it. If you guys want to see more like this, go ahead, leave a like on the video, comment down below, let me know what you guys would like to see. And above all else, remember, stay sneaky!